Alright, welcome back again. My name is DeMalie, and let's get started with today's DeepSeek overview. So let's begin with introduction to DeepSeek and its fundamental. In this section, we will explore DeepSeek R1 and the company behind it, and we will take deep dive into DeepSeek ecosystem, covering its benefit and the key concept and all of that fun stuff. So what is DeepSeek? So DeepSeek is a Chinese AI company that specializes in building AI models, particularly open source AI models. And why is this important that we want to take a look today? So open source allows developers worldwide to access and use these models without any cost, and this is a significant advantage compared to priority AI models, which are often locked behind paywalls. So introduction to DeepSeek R1. Recently DeepSeek launched DeepSeek R1, an open source model with advanced reasoning capabilities, and this model has been designed to compete with and even outperform OpenAI's #1 model, ChatGPT, and the AI community has been buzzing about this because DeepSeek R1 has outperformed OpenAI's models and on certain benchmarks. And why focus on DeepSeek R1? While we discuss DeepSeek R1 today, the fundamentals we cover will apply to future AI models as well. So the reason behind we focus on R1 is because it represents a major step forward in AI reasoning capabilities, and this model competes directly with OpenAI reasoning models, excelling in problem solving, coding, natural language understanding. So the benchmark performance here is that as you can see the graph on the list slide, compare DeepSeek R1 with OpenAI models, and the blue bars represent DeepSeek and our performance, and it's constantly scoring higher in reasoning based tasks. So as you can see here, we have 7.8, and OpenAI is 7.9.8 and 7.9.2 for OpenAI, and it keeps 7.2.6 and 6.2. So as you can see, DeepSeek is always overtaking an OpenAI. So some of the key capabilities include problem solving, solves all algorithm and mathematical problems step by steps, and then also conventional AI maintains context awareness and generates natural dialogue, and then also code generation and optimization. Complete function, detects bugs, and support multiple programming languages. And it also has text processing and NLP, handles summarization, translation, and content generation. So the key takeaway here is DeepSeek R1 has raised the bar for open source AI models, making powerful reasoning and accessible to everyone. And this marks a major milestone in AI development, providing developers free access to open AI models with higher level reasoning capabilities. So let's take a look at R1 capabilities. So as you can see, it's able to do some text processing, is able to do some translation, summarization, content generation, style adaptation, and then when we come to some problem solving, as you can see, it's able to do some algorithmic solution, logical puzzles, mathematical computation, step-by-step reasoning. And then we have conversational AI, which is context awareness, personality, consistency, natural dialogue generation. We have multi-turn conversation, and then also we have code generation for developers, so you can do some code optimization, you can do function completion, bug detection, and multiple language support, which is really good for R1 capability. So this is really good milestone for DeepSeek. So let's go to foundation core architecture. So here's an overview of the core architecture. This is the foundation side of things. So DeepSeek is based on transformer architecture, which pretty much most modern models are based on. Of this architecture, this is we have transformer architecture, but it's also implement advanced attention mechanism, which makes it even better utilize the state. And then that's why it actually made this such a revolutionary model, reasoning model, and also supports multiple model size through what we call distillation. So we'll talk more about that, but let's go ahead and look at an overview of what we just talked about briefly. So as you can see, so when we talk about the core architecture, let's look at sort of everything laid out. So at the top, you can see that we have a deep core. Right here we have the deep core, and then it's a foundational model, which is the main model really without any alteration. And then at the core we have then the transformer also. So we have what we call multi-head feed forward, and that doesn't make any sense at this point, but it's okay. We have the attention mechanism, self-attention, cross-attention, and we have the training side of things, pre-training, fine-tuning, variant, and so we have the base foundation on foundation 1 and distill. Now let's go ahead and kind of look more through this diagram here, so we can have more sort of idea of this architecture, how this come all together. So if you look at this diagram here, they are key components of what we just saw. So at the top we have everything. What we have is what we have input text that goes in, and all of this has to be transformed into tokens. So essentially we take raw input text that is processed by system from instant, let's say hello world, and that would transform into tokens, something like that, and hello and then the world, right? So these are tokens, and that is actually what is fed through the core processing. Okay, and now keep in mind that tokenization is very important, because that is what large language models use to process data. So the text is converted into tokens for processing. That's what it's taken through the core processing. Now what happens here is the core processing is very thin, very simple things. So, well, not simple, but the idea of it is very simple. The main focus here is that there's got to be some sort of understanding the relation between words that are coming in. So when we talk about this transformer architecture, what that represents is it represents the core architecture, which includes what we talk about self-attention and feed-forward networks. All of that to say that these are the inner layers of the large language models to actually create the result that we see, right? So to process all that information, the text that comes in and is transformed into tokens. So the core processing here, understanding the relation between words that are coming in, processing the whole information that is coming in the data and everything, and also creates this information flow that goes through this core processing, that at the end of the day then the machine, or in this case the model, is going to be able to do prediction, which at the end of the day brings and gives us the final result that we are looking for. That is very high level overview of this whole thing here. And then the model variance side of things, we have what we call the base model, and this is the original model. Okay, as you can see here, the base model, and this is the original model, and this is the distill. We also have the distill model, and these are smaller, which are faster when we run them, because we can run them locally when we don't have as much GPU or as much computational power. And because remember, these large language models are very intense, computational intensity, and also we have this quantized mean. Quantized just means we take a large language model, really large one, and then we compressed it. So we take this quantized, so we take really large models, and then we compressed it, a version of the large language model. Now going through a little bit here just to take a look, another overview of this pieces that we have talked about. That's all that happens inside of this core processing. So we have this transformer. I said this transformer architecture is the core because it includes what we call the self-attention and the feed-forward networks. So the self-attention layer, what is that well, it's just the layer that handles the attention mechanism in transformer. Okay, so this deals with finding the relationship between words and creating the circle and a relationship between words, so that the model will know what to do next, what to pick, or what to predict next. Now when we talk about this feed-forward networks, these are the ones that do processing of data, which uses this what we call the fully connected layers. Okay, we don't have to go into too much detail, but that is the idea. Then we have the layer normalization, and the layer output for stability, and many other things, and residual connection. These are the ones that keep connection, which help with training deep networks. Okay, so that's a lot of jargon here, but you have an idea. So just keep in mind this core processing, which includes all of this, is where we have this understanding of relation between words, the processing of information, and make sure that information is flowing correctly through the whole process. All right, so let's take a look at the model variants with a little bit more details, because I think it's important for us to understand that in grand scheme of things. Okay, so here is a diagram. So we have the model variants at the top, and we have this model variants at the top, which then we have these categories. So we have the base model, we have the distilled models, and the quantized version. So let's break all of them down so that we can see each one at once. Okay, so the base model, what is that? Well, the base model thinks of this as a full-size brain, so it has the highest accuracy, but also it needs powerful hardware. That is the main problem here, is that if we want to run this, it's very hard for us to run locally because it's very intense. So you can see here it has usually 4 parameters, 175 byte, and this has billions of parameters, right? Neurons and layers and networks and everything. So the great thing also is that this has the highest accuracy because it's full base model. Okay, and again, GPU required. That means it really needs to have really good GPU for this to run without any issues, because it requires secondary GPU and memory. So if you have complex tasks, then it will be the best to use, which is the base model. And then we have, now if we want to go back to seeing different models variant here, which is going to be in this case the 2, we have distilled models and quantized version. Now what is the difference here? Well, the distilled models is like a smaller copy, or copies in the case of the base model. So you can see here earlier we had over 100 byte, right, billion. Now we have medium, small, and tiny, and even smaller than that, as you will see. Okay, so these are the models that have been created as smaller copies, and they are smaller and each size optimized for different uses. So for instance, the medium will be good for, will have a good balance, and I should say, of power and in speed. The small one is faster but still very capable, and that is tiny one is fastest, basic tasks only, and can perform basic tasks only. So it's not as fast or as convenient, or in this case complex in many ways. But then we have quantized version. These are different in that same model, but a number stored more efficiently. So the number inside has stored more efficiently, and we have different precision. So here we have 8 precision, 4-bit quantized, faster, and then we have also faster inference. So what does that really mean? Well, first we need to think about the trade-offs. So these are slightly lower in accuracy, for instance, for faster processing, for less memory uses, and they can run on a simple hardware. So if you are running really not so modern, or that doesn't have a lot of GPU or CPU memory hardware, then quantize, that's probably what you want to run. So analogy that I like to think when I think of this here, these are models. This model variant are their core is the base model. It's like super computer, and then distilled model, they are like laptop or tablet, and then the quantized, they are like smartphones version. So think that so I think that's really nice way of thinking about this. And keep in mind also, I'm going to go a little bit here so we can see the whole picture, that each variant has its very use case. Okay, so as you can see, we want to talk about open versus closed source large language models. So when it comes to pretty much software in general, but also in AI world, we have different kinds of models. Okay, so we have the open source and we have the closed source models. Let's take a little deep dive up onto both. So let's say let's take a look at the different and really understand, I think, the power behind both of them. When we talk about open source models, we have a lot of benefit. One of them is transparency, which means we have this fully visibility into the model architecture because it's open, so we can do something addicting for training data resource and process. We can have clear understanding of the model limitation as well, and also the ability to verify ethical considerations. So transparency is huge here, and then we have this ability of customization. So we have this customization flexibility. And what does that mean? While it means we are able to freely modify the model architecture, if we want to, we can customize by doing fine-tuning for a specific use case. We can integrate with existing systems. So essentially we have control over deployment environment. And then we have community collaboration. This is the heart of open source models, because now we have this shared knowledge and improvement and rapid innovation, because we have a community that is contributing. So this is this go fast, and also we have this collaborative problem solving that happens in the community, and we have this diverse perspective and application. So it's really awesome. But also more important, the cost. Open source, no cost per token or API usage is fees, so it's free, and usually it's one-time hardware investment. So just go buy a laptop or a computer, whatever hardware you want to run these things on, and then you are good to go. And also it's easy for us to scale because no need because it's free, right? And no need cost. And then prediction in long-term cost, so we know exactly how much we are going to spend and how much we'll be investing, especially when it comes to long-term. So it's going to it's not going to be like, okay, today is $10, but tomorrow, because I don't know, as somebody owns this, they might say it's now $45 or maybe $50 or $70, you know. So that's just an example. So we have a lot of control, but also we have challenges. And one of the challenges here is that this initial setup that can be complex, right? We have hardware requirement because these are running, and we have different levels of this model. So you need to have hardware requirements met for this actually to work, and also maintenance responsibility, because now you have responsibility for maintaining the model yourself. And we have performance optimization needs, as you know, and with all good things are free, we also have some issues of optimizing and must optimize to really fit our use case and each and every time as well. And then let's talk about the closed source LLMs. So now when we look at the closed source large language models, what is that? Well, these are large language models where we don't have any access to such as OpenAI and many more others out there. And so we have few benefits. Of course, the benefits is that these are very reliable because they have regular update and improvement, and then it's professional support because you are paying. So you have people who will help you if you get stuck, or usually have stable API access because, again, you are paying for it, and consistent performance. That is huge. And one, because if you are paying for something, you want to have consistent performance. So also you have ease of use. This is big one, because it's just plug and play usually, because simple, you can plug in API integration and then you have it ready to go. And it's usually managed somewhere, so has this managed infrastructure in the cloud that we don't have to worry about. And so no setup is also required, and you don't set up anything. Just go and get APIs key, and then you're ready to go. And it's very quick for deployment because it is already there. Okay, so and you don't have to do much. Now we can also look at the enterprise features. So these are closed. When we talk about these closed source models, they're really good for enterprise because they have service level agreement, they have compliance, certification, professional support, and of course security guarantee. So that is huge as well. And for in terms of performance, of course, it's better in most cases because everything is optimized, and because it's run in optimized infrastructure, and it has latest improvement because they are usually huge team of smart engineers working on this system, these models. It's also scalable resource, and it's easy to scale, and also professional monitoring. So they usually provide all the professional monitoring, so you can monitor your usage and all of that. But also, of course, there are some challenges we have said, and number one is what we there's a cost attached to that, and the data privacy concern. This is huge. Why? Because if you are using these closed source large language models, that means you are passing along data that you don't know what will be doing with data, or what they are going to be using your data for. So private data, it has limited customization. We don't know, and it's closed but so we don't know what happens internally, and also it's vendor locked. So once you start using them, you are locked into whatever they say that needs to happen, okay? Because you that is something they have control over. And if you are using to build large-scale application, then you are locked into whatever they have to do. Now we are going to do deep dive into DeepSeek R1 and look at the DeepSeek chatbots, look at some LM Studio, and we will also be using chatbots, which is UI tool that allow us to actually use different large language models. And of course later we are going to use API and some SDK to do all of that locally. And then so we are going to also do local installation, of course, and go out from there. So initial installation and setup. So the initial installation and setup, so we are going to be using DeepSeek website first, the chatbots that everybody has access to, and we are going to download our model locally through LM Studio and download our OLMs and also as well. And so of this going to be happening soon. Let's go ahead and talk about the hardware requirement, and then we can jump into it. So the hardware requirement, so now as you can see, we have minimum of 1.5 and a CPU here is 8 core CPU, 16 gram RAM. Recommendation is 7B model. CPU is 12 core CPU, and then 72 gigabyte RAM. And then we also have the optimal full model, and note best for producing use performance, fast response, full capabilities, and recommended 7B models is good for most use cases, performance, balance, performance, and capabilities as well. So development and integration, now that is the time for us to look into the development and integration. So we have used Ollama, and then we have used LLM and Studio and all of that. So we understand how to use all of these tools to use RM and then chat with it and play around it, and which is wonderful. But the main point here is that we want to set up locally so we can start developing and creating application, at least good prototype locally. So let's look at local APIs. The benefit of having local APIs versus DeepSeek APIs, which you saw you still have to pay for, is that for local API, number of one is free, which is nice, but most importantly it's private because it's one of your local machine, and also fast interference, which means when we do the course we receive the information right away because it's local, whereas Deep API or any other API, of course, is running this model, it's costly and not private, and this is some sort of latency. We have to wait between the time that you send a request and the time you receive the response. So these are advantage and disadvantage of local APIs versus the DeepSeek. And so next I'm going to show you how to use local API to, in this case, running Ollama. And when we run Ollama, which is running on the background, it will have an interfering local endpoint, which we are going to use to run invoke local using code using Python in this case. So let's go ahead and do that. So first, let's go to deepseek.com, as you can see, and this is what you should see. There's a lot going on here. As you can see, we are recording this video. We have DeepSeek R1 and it's now live and open source, revealing OpenAI's model when it is available on web and API. So we go ahead and click for details, and then go ahead and click and see what will happen. Okay, so this takes us to DeepSeek documentation, and this is where all you see all of these different things about the release and all of that. So you can see here, recording this video, the release, it talks about performance on par with OpenAI, and it's fully open source models, and technically report MIT license distributed and commercially free, which is nice. And of course we can have try DeepThink at DeepSeek. So I'm going to click that, and this is where you see, and now I'm able to see this because I've already logged in. So in case if this is your first time, you will have to log in to get here. So it's very easy, just create an account and you should be able to go into that, and so you can see this user interface. There's a lot going on here, not quite, but say hi, I'm DeepSeek, and now how you can help you. I can say hello world and hit enter, and most likely we are going to see something in response in return. Okay, not very interesting, but what's important here is that we can see what we now have, this DeepSeek R1. So you use DeepSeek R1 to solve reasoning problems. So if I click that now, I can say, for instance, what is 3x plus 1 minus 2 and it's equal to 18, something like that. Okay, let's see, it's simple, it's going to do something. I'm going to click and enter, and now it's you can see, okay, let's see. So the user asks, so this process of thinking, reasoning is happening. So if you're going to go through this thinking process, which can toggle back and forth, and it's giving all that. Okay, so it takes a minute because it's thinking, trying a few things before it gives the final results. And of course later we get the result for us, seeks to solve the equation and goes through the methods, the steps to do so. Equation becomes this very good, and in isolation of that in verification. So answer here is 19/3, and which is okay. So this is very good, and the most important thing here is that we have this thinking that is happening, the chain thought that is happening back and forth. And now this is not new in many cases, but at this level, because the way that it thinks, in this case DeepSeek, I should say, model R1 has been trained and has been regulated to do things, and it has higher level of thinking, higher level of reasoning. That is the reason why this is such an amazing deal, and it's a big deal. Okay, so this of course is the place to use this for free. And now the thing also, you can notice that we have the search enabled. So you can actually do something like tell me a joke related to new, let's say to news regarding I and DC, on something like that, just to see what will happen. So if I hit enter, you can see, sorry, DeepSeek's search service is busy, please disable search or try again in few minutes. So this is a good point to show you something that is going to be more apparent as we go through the course. And actually the whole model of this course is that we are going to actually use DeepSeek R1 locally. And why is that? Even though this is for free and it is nice, and when it works there at times, because even though it is free, we don't have control over this, right? So using this case, this interface, so you can see what we can use certain things, even though search is very important, but sometimes maybe not as important. But still, this is shows you that even though DeepSeek R1 itself is open source, but when we use an interface that is connected to DeepSeek company, then we pretty much are limited to what you know, limited to what it gives you. And that is another thing of having this sense of control when you have your own models locally that we can control. And then on another thing also, we chat deep is chat DeepSeek is, in this case here, all this information is going somewhere that we may not know what's going on to do with. So we get it for free, in this case the chatbot here, but again we don't know what's going to happen with our data and so forth. So this is one way to use DeepSeek chatbot interface with R1, as you see. So what I want you to focus on is the capability here. So I encourage you to go and ask even harder questions to see how it performs. So now we can we saw some of the limitation that comes with using this chatbot by DeepSeek. It's wonderful, as you can see it works, but we are developers, we want full control. So that's why now I'm going to show you how to use another tool, a user interface called LMS Studio. What this does is it allows you to experiment, as it says here, with other elements, different elements on your computer, and then you are going to have a chat interface and a program API. So this is really nice in a way, because you have this place where you can have more control, different elements, different models, different versions, and you can chat with them. So let's go ahead and install this. And first of all, you come here and it's LLM Studio. You can just go ahead and search online LLM Studio and go ahead and download now, depending on where you are. If you're on Windows, of course, this is what you need, and I'm on Mac. It gives me here download LLM Studio for Mac, and I'm going to go ahead and download it, and it gives me change this to a Mac OS to make sure I'm getting the correct one, and then we can try again. And I'm going to just drop in an application. Okay, so I have the application running on my Mac, and I'm going to just go ahead and say experiment and develop with elements locally on my computer. So let's go ahead and get you a first one. So you see it gives me DeepSeek Distill Queen, which is really nice. It tells you that this is indeed what's up right now. So I'm going to go ahead and download it real quick. So it is 4.68 gigabyte downloaded, and it's going to go ahead and start downloading here. And it says here, go ahead and explore other things while things are being downloaded, and can go ahead and see there. So you can see that we have this chat select model here. I don't have any model. I can go ahead and download LLM3, which is not what I want, so I'm going to just wait a bit. But you can see the user interface is pretty much the same. I should say the same, but very similar of what we have seen before. So you can see here it's still downloading. Let's give it a moment. After a few moments, you can see that I click here. I can see I have this DeepSeek R1 Distill 0.7b. It's similar version, about 74.38 gigabyte. I'm going to select that, and I can do some configuration here. I'm going to leave as the at this point, and I'm going to go ahead and say load it, and I'm going to wait a bit, and this is going to load into my LLM Studio, and in a few moments I'm going to be able to hopefully use it. And the great thing also is that it says system resource usage at this point is 4.51 gigabyte, and CPU is at 3% being used at this point. So if I click here, hopefully it show me something, but anyway, it's all there, and let's see if all is good. And as you can see, it looks good, and it gives me the contents window is 4098. Okay, so the amount of token that can handle at once. So what is the capital of France? Let's see what happens. That was really fast assistant. DeepSeek Distill says capital of France is Paris. Let's say 45 or 35. Plus 1 equals 200. As you can see, it's thinking. So this is awesome, because this is the same thing that we saw before, but this most important thing here is I'm I'm running on my machine. That is good, and it goes through everything, and this gives me the actual response, and which is very good. Okay, now there are many other things that can do. Of course, we have developer command line where you can see other things, but the point here is not going into all of this because you can all do it on your own. My model shows you all the models text embedding. You can add some text embedding that have happened, but at this point here is where you can actually use this again. This is locally, which means you have installed or download the R on your distill 7b locally, and it's running. So now you can do the same thing. Tell me set up the best joke ever. Tell me how to set up the best joke ever. And as you can see, it's going through the process of thinking. Okay, so we go, it gives me all the thinking, of course, but then the top-notch, the setup, top-notch joke, follow these steps. Okay, so what at this point, this is again show you what is possible if you want to use a nice chatbot interface that is locally. You are able to download your own and then large language models, and this is where you will use it to download things. Now this is great and all, but we are developers, so we want to have more control. So as I said, this is a nice user interface, and we have made progress in that. We have downloaded our own model locally, and we can chat with it for free. Now the other level here is for us to be able to actually download this model using Ollama, which is a tool framework that allows us to do pretty much the same, but more as a developer, more as a granular, more on a lower level, so we have even more control. So this is what we're going to be doing in the next, because then we can have keep running all our background, and all the model in this case are on one downloaded locally, and we can use local endpoint to invoke, like we will invoke an OpenAI key or some sort. So that's what we're going to do next, but before we go that, I want to show you another way where you can actually use OpenAI. But okay, so let's go ahead and do that. The other thing also before we move forward is the DeepSeek also has an API platform. If you click here, you can see that that's another issue. Right at this point, we have this our website is currently under maintainable. We will, because these things are not going too well, they have actually experienced some cyber attacks, so this is servers are down. Another thing to let you know, another reason why you want to have more control, because even though this is free, because even though they provide open source model, we'll still, if you're using what to use our APIs or anything, because in this case here the API is not free because they are hosting everything. But another reason to let you know that whenever you are use a company or closed system, this is what happens if you are using the API and then things are not working. Well, that's what you get. So another way I want to show you where you can go and get an API key. But as you can see, it's not working but by the time we are watching this video, so you're going to be working, but which means you can go ahead and get API key. Well, have to pay some money for you to be able to use that, which is not the topic of this video, of course. Anyway, but I just want to show you the possibility. So this shows you so we're going to go to ollama.com. This is what most likely see, and so it says here, get all the running language models so you can handle Ollama 3.315 for DeepSeek and VI4, Mystery, Gamma, and other models locally on your computer. So again, as I said before, you should have Ollama set up locally, and it's easy to do that. So you go ahead and download, and then you go to Mac OS, and then you can go ahead and click download. Depending on your system, you can go ahead and click download for you to get it downloaded. It's fairly easy to do. So once you have everything set up, you can go and click here, and you can see all the models. Zoom in, and this is how you probably see. You can see search, and what you see the first thing there. Let me make this smaller again, and the first thing you can see DeepSeek R1, right? So this tells you these are the most famous popular models. Let's go ahead and click that. So when you come here, you can see it talks about this model. DeepSeek first generation of reasoning models with comparable programmers to OpenAI. One, it says including 6 dense model distilled from DeepSeek R1 based Ollama and Queen. So you have C here, we have 1.5 billion. If you click here, you can see all these different flavors that you will have. Right at the bottom, you have 671 billion model here, which is 404 gigabyte. Obviously most of us aren't going to be able to run this, and as you know from the previous lesson, this is the most optimal one, and but we're going to do that because most of us, as I said, don't have the bandwidth computer with this kind of bandwidth to be able to run this, but most of us can at least run up to 32, but it's going to be really heavy on your computer. So for the purpose of learning, showing you how to pull this model, we're going to use the 1.5 gigabyte, and then go 1.5 gig, sorry, 1.5 byte. And if you click here, it's going to give you some more information about the models updated 10 days ago, and a few other information here about the models, about the parameters, the template and licensing, and all of that. And if you scroll down, you can see you can read more about it, and most importantly, you can read about how to run, and this is the command you will run to install DeepSeek. Now in this case, DeepSeek R1, okay, this is says 671. That is not what we want, obviously. Okay, so I want to go down and find this one, and then we could probably actually use this 17 byte, but to make sure that all of us who are watching this video and able to run this, because we all have different requirement hardware and requirement, this should be something for sure that we can all run. So I'm going to start with that, and the next question is how I pull this in. Well, this is why you have to have it installed, and then once you have Ollama installed locally, it should be fairly easy looking for a terminal. And I'm going to say in terms the what I say, and I'm going to do here, I'm going to say Ollama list, and then if you have everything set up, you should be able to see that you have a few things that have been added, or a few models as well. So and you have to you can say run or pull, and then you can get the actual result. So in this case here, I'm going to copy this. If you run it, it's going to run it, and if you have it already, it's going to install it, and then you can have it. So come back here, and if you, in case you say Ollama run DeepSeek R, and then you click enter, and for me it's going to go straight and go run it because I already have it, and in your case, because you at this point you shouldn't have it, it's going to go ahead and go through the process and to get you set up and have your R1.15. so now I can say tell me how to set up a good joke, and just like that, it's pretty fast because it's using this locally R1, this guy here, DeepSeek R1 15.5 is very cool, and I can say maybe it's maybe a bit able to solve even complex problem as well. So let's say solve the following equation. I'm going to say 45x is equal to 9, and you can see it's going through the thinking process. As you can see, we think all these things at the first different light, and so I can go and say forward slash and clear. By now this is the it's even able to use it as an API, and how do we do that? And this is what we're going to get into doing in the next video. Make sure that you have all that set up and that you indeed have it, say Ollama, and you have all the list or LZ. You should see it, at least this one or here installed and set up. When we go visit, if we go back to DeepSeek and just click anywhere here, really just look out for API docs DeepSeek like this, and you will see the news and everything. Because I'm zooming, I'll have to click here, and you can go on to quick start and right click, open close like this. And now let's go for your first API call. So what this means here is where you can use the API format. It's compatible with OpenAI. What it means is that we can use the same OpenAI SDK per se and sort out hacks. So that we can put certain information like API URL or base URL point to our local Ollama running R1 locally. So this is what we have, the parameter that we have, we pass the URL. If you want to use DeepSeek API, this is what we will do. So you can see that they even have code here for Python to see how this will work. So what we will do here is that we have this OpenAI SDK that we are using, and we will have to do pip still install OpenAI, and then we will pass API call. You will see we're actually going to just put nothing or just say Ollama, and then the base URL is going to be different, which I'm going to show you how in a second. So let's go ahead and do that real quick here. I'm going to show you in your code. So first, all you have my virtual environment running. Remember, you are going to have all this code, so no worries. So let's start with this DeepSeek Pi. So at this point, if it's indeed empty, there's nothing here in. So let's go ahead and get started. First thing I'm going to do is first of all open my terminal and say make sure the virtual environment is running, and say pi install streamline OpenAI, and very good. So once you have that installed, all we need to do first, say from OpenAI import OpenAI as such, and then we are going to create a client here which is going to be OpenAI, and we are going to just pass all the things that we need to pass here. Here the first thing is going to be the API key, and usually you pass the real API key, but we are going to because we are going to do all this locally, I'm just going to say Ollama are empty, but Ollama. Now the important part here is that we need to use the base URL. We are going to use the HTTP as API, so the local one, which is HTTP like this, and then we say localhost instead of 8000, it's actually 11434. And then we say /v1, and then we finish with /. So this is very important. We are using the OpenAI SDK, and we sort of hack again quote unquote by putting Ollama or OpenAPI key, and then we have to change this to localhost and exactly this point 11434 and v1 like this. So now we have this client which is going to be using this local Ollama. So you have to make sure Ollama application is running in the background, which is serving in this case all our models to this endpoint. So all we have to do next is create a response using the client, and then we are going to just say what we always do, completion, and then create. And then we are going to pass a few things that we need to pass, just like we always do. First, we are going to pass the model, and then we have to pass some message, which is going to be a list of messages that we have seen before. So this message, I'm going to just go ahead and get what I already have, so that we don't have to repeat ourselves. So what happens here is that I'm creating the role system, the role a system right to prompt or to a ground or a model, and then I have a content, you are helpful assistant. So you have seen this many times. Now what I'm going to do here, we have to make sure that we change this. This has to be the same name as we see, or we say our model that we install locally. So a good way to do this, you can open any terminal or command line per se, or let me say Ollama list. And then so in this case I'm going to just use this, let's use this one here, 1.5 B, and because I have seen it's okay whichever you want to use, and it has to be the same name. And I'm going to pass it like that, and I'm going to say stream pass it to false because I don't want this stream. And then I'm going to just print the response and content like that, and then that's it. So now this is the power where you're able to hijack or quote unquote, maybe it's a strong of words, so that we are pointing this OpenAI SDK function here. We are pointing that to our local host where we serving our model, in this case R1, and then we need to specify the model we want to use, which is this one here. Has to exactly the same name as we saw. So here we build me a snake game. I say something simple, or tell me yes about to yes about to deep learning. Okay, so let's go ahead and run this real quick. So in the background, it's actually going through the process of thinking and everything, and I'll show you next how to turn on the stream, and then we can actually see things happening because we are not streaming. It's just wait until the completion is over, then gives us the result, and you can see we have these lags that say thinking or thinking. This is very important because that tells us that we are running a thinking model and are very good, and at the end it ends with a endthing tag, and this gives us as the result, which is very good. And now I'm going to change this to true point through the part where it says streaming, and then I'm going to stream everything so we can see exactly as we have seen before. Now it's going to be a bit different in that I'm going to open this, let's clear, and then let's run it again. You will see that now it's going to stream. Look how fast this is. Oh, that's pretty incredible what you can do. And actually you can get 7 B model, and you can try to test up to the I think 34, I believe, or the highest, not the highest, but just keep going down until you see whether your computer is going to make things a little bit difficult for you. And what I can do, you can see that it gives me all this result, and it was streamed along. And let me change this perhaps to say something like solve let's say solve the problem of world hunger, and let's see how this is going to do. It should be interesting because that's a big problem. Nobody's able to really solve it yet, so it's thinking, going through the process, and apparently I was wrong. Looks like R1 is able to actually give us a solution, and we now have to implement and solve the world hunger problem. And there you have it. The fun part here, the amazing part is that now you have control in that you can use the API locally and the model locally and start building stuff.